Dear friends, prepare to go on the sometimes shocking and always electrifying tour through the early history of the most amazing technology ever devised and created by the genius of mankind. Since deep antiquity, our primitive ancestors have been in awe of the mighty heavenly displays that are thunderstorms. Their ignorance of the scientific nature of this phenomenon did not save them from the occasional shock, which replaced the awe when the careless ones left their caves for a closer look. Besides the zap from the heavens, one could encounter a sizable one from certain sea creatures, such as this mean-looking eel, which likes to recharge taking a vigorous swim. It was the ancient Greeks, to our knowledge, that first learned to create meager amounts of electricity by rubbing pieces of amber, called electron in Greek. They could use it to pick up tiny things for amusement at their famous parties. Ah, but who hasn't enjoyed the power of charging up on a carpet as does this adorable pet of the famous engineer and hero Dilbert? Of course, more efficient methods have been developed, such as this beautifully built frictional electrostatic machine which could deliver quite a spark or accomplish other hair-raising scientific demonstrations. Of course, hair standing on end is not an effective way of storing an electric charge. And a better way was devised in Leiden, Holland in the middle of the 18th century. The device, which became known as the Leyden jar, consisted of a glass container with the disconnected metal surfaces on the inside and outside, making it the first capacitor. The Leyden jar, properly charged, could deliver quite a wallop of a shock, comparable to a lightning strike. It is probably that fact that motivated the adventurous American hero and intellectual Ben Franklin to try to catch some lightning into such a jar, and to finally prove that lightning is indeed electricity. Coulomb, a French officer and scientist, was inspired by Franklin's various experiments and made a contribution of his own, building an apparatus to measure the quantity of electric charge and deriving the law for calculating the force between two charged objects. It is to the Italian Galvani, who loved to dissect frogs, that we owe a great leap in knowledge. He had a static machine in his lab and noticed dead frogs twitching occasionally, even if they weren't connected. After painstaking experimentation, he observed that he could animate the dead frog muscles by connecting two different kinds of wires, as shown in the picture. He thought that the animal was the source of electricity, which perhaps was related to life itself. Pretty soon there were reports of drowning victims coming back to life after getting a shock, from Leyden jar perhaps, and Mary Shelley used this knowledge when she brought to life a famous monster. Frankenstein was published in 1818. And we still bring people back from the dead, well, almost, by judiciously administering electric shocks using capacitive defibrillators. Clear! Another Italian, Alessandro Volta, is the genius to whom we truly owe the birth of a technological era. He admired Galvani's work, but thought that it was two metals, not the animal body, that were responsible for creating electricity. After some experimentation, Volta built a pile of elements consisting of paper soaked in salt water and sandwiched between plates of different metals, such as silver and zinc. He now had a source of electric current which did not need to be charged like a Leyden jar. Thus, by 1800, Volta created a battery, but he didn't even bother making much of a spark with it. Plenty of other experimenters picked up where he left off. In 1802, a Russian scientist, Vasily Petrov, built a voltaic pile of more than 400 disks and created more than a spark. His continuous electric arc was later to be used in welding as well as illumination. Also immediately after Volta published his invention, Nicholson and Ritter used the battery to decompose water into hydrogen and oxygen. Pretty soon, bubbles were used to create first electrical messaging systems, with wires stretching up to a few kilometers. Battery-powered electrolysis led to many advances in chemistry. In 1807, Sir Humphrey Davy discovered potassium, sodium, barium, calcium, and magnesium using this new technology. Danish physicist Hans Christian Ørsted pointed the technology in a new direction when he discovered that an electric current moves a nearby compass needle. Not only did this connect electricity and magnetism, but also allowed to really move things with electricity. Electromagnets made with coiled wires were soon refined and formed the basis for motors and relays. In 1825, the British inventor William Sturgeon lifted 9 pounds with a 7-ounce coil and a single-cell battery. Several electromagnetic telegraphs existed already by 1835 when Samuel Morse created a coding scheme which allowed communicating with a single set of wires. The telegraph soon spread along the railroad lines. Delivering messages on horseback became practically obsolete. Distributing messages by electrical signals is no simple matter, however, especially when networks are involved. Understanding how electricity is distributed in a network of conducting elements was developed by Kirchhoff, and to this day his theory serves as the entry point into the profession for most electrical engineering students.